Alright guys, so now you guys have the steps for completing the square from above. Let's try example C here. And we'll go ahead and do it here algebraically, but we'll also give you the visual of what's happening at each step. So first, when you guys solve by completing the square, you have to set a is equal to 1, which it is in this case. Next, you're going to be asked to move the constant to the right-hand side. So here I'm going to subtract 7 to both sides. So in doing that, I'm now left with x squared plus 6x equals negative 7. Guys, if I want to see that visually, I'm going to show you this with this visual. So x squared, here's x squared. So I'm going to write it as x squared. And we know that's x times x. And then plus 6x. So this will be representative of 6x, where this is still going to be x because these are the same. And then I'm going to have a 6 here on the side. Then that's going to equal to negative 7. So right now what you're looking at is this equation, but here's a visual of the same equation with some shapes to represent these different terms. Next in the process, we're told to identify the b number. So that's going to be 6 in this case. I'll put it here on the side. So our b value is 6. We're going to divide it by 2 and then square it. By doing this, guys, that's how we complete the square. So we take the b value, we divide it by 2, so it's 6 divided by 2, and then we square it. By adding this value, which happens to be 3 squared, to both sides of the equation, this is what's going to complete the square. So if I add 3 squared to here on the left, and then to keep it balanced also here on the right, what I've now done is I've completed the square here on the left hand side. This piece here, this expression is a perfect square. It's a perfect square trinomial. So I can go from this quadratic expression right into factored form. And it's going to be x, this perfect square will be x. And then here, 3 squared is 9, but notice how the square root of 9 is equal to 3, so this value 3 is what comes in to this factored form. Now why does that work? Oh, actually guys, before we do that, let me finish up this side of it. On this side, negative 7 plus 3 squared, 3 squared is 9, so 9 minus 7 is going to be 2. So the question is, why does this all work here visually? So why does taking the b number, dividing it by 2 and squaring it, why does that complete the square? So let's check. Guys, if I take this b value, this 6x, if I were to divide this by 2 or cut it in half, like that, then I'd be making 2 little shapes that are going to be 3x, and then this one's also 3x. That's how you get 6x. So if I were to take my x squared, sorry, I meant to point there, my x squared, so if I redrew that here, x squared, and then I took these little 3x's that I cut in half, if I attach them here to the x squared, then what I'm going to have here is, this is 3 and this is 3, this is 3x and this is 3x. If you look at what I have here now, if I were to add this piece here to finish making my whole square, this would have, by 3 times 3, this would be 9. So here, if I add 9 to this expression, I complete my square. Well, look what here, what did I add? I added 9 to this side to complete the square. So that's why this is working visually. And as a result, what I get is x plus 3 times x plus 3. That's where I get my x plus 3 squared. That's where this comes from. Because again, this is just a visual of what's happening here algebraically. And when you guys solve these, I'm not going to ask you to do both when you solve, but for the notes, I want you to kind of get an idea of what's happening kind of as you go through these steps. To finish now, I can take a square root, So I'll take a square root of both sides. So x plus 3 equals plus or minus the square root of 2. Then I can move this plus 3 by subtracting, and I end up getting x equals minus 3 plus or minus the square root of 2. And in this example, I can't do much more than that to simplify, so I would stop there with that response.